guess we'll get started, and I'll open it up. But we have three different speakers for the slot, and we're kind of, the overall theme is the IoT security in the Arm open source area. So the agenda, well, like the title says, this is IoT security. I'm going to speak to some of the Arm V8M topics and how that impacts Zephyr. And we're also going to have a presentation or a little bit of a chat about the auditing of the secure open source software. So these are kind of out of order, so I'm going to skip to the Arm V8M and Zephyr. So this talk is meant more as a discussion, so it's not going to be, we're not going to dump a bunch of information on you. We're going to go through some of these things, but we'd really like to have kind of a back and forth. So if you have any questions, please raise your hand at any time, and we'll stop and we'll have a discussion. So today, in Zephyr, we have some support, or we have support for the Arm V8M, and what that means is that the Arm V8M supports two execution environments. There's a secure environment, and there's a non-secure environment. Nordic added a bunch of support for the secure environment such that you can actually build an Arm V8M target right now, run it in a secure environment, and that also means that you can handle the security faults that happen, and also they added support for the MPU that changed actually between the Arm V8M and the earlier ones. One of the nice things about that is the new MPU actually supports start and end addresses, whereas the earlier ones were power of 2 type of thing. So when you were setting up regions, it was kind of difficult because when you are doing linking, you're having to do power of 2, and it's a real pain. So that was quite nice when they changed the hardware on that. As far as board support, there's only a handful of boards out right now that support the Arm V8M. There's Nuvoton has one, Microchip has one. There's of course the Arm MPS2 and also the Arm Musca board, which has an M33 on it. The Musca board is kind of a limited access board. You can request a board from Arm, and they may or may not provide it to you, but that's really all the boards that are out there right now. As far as the current support in Zephyr, we have some PRs out there for the MPS2 and the Musca. Those are in review, and they should actually land sometime this week. So if you have one of the boards like an MPS2 or a Musca, you can then try it out. As far as Zephyr's concerned, there's really only one scheduler in the system at this time. So when you're talking about secure and non-secure environments, even though you may have a secure environment, you only have one scheduler. So when you go and you do a secure call, you transition over to the secure environment. It's a blocking synchronous thing. Once it's done, it comes back and you continue on with your scheduling. In the future, however, that may change, but however, that gets very complex. So if you start to think about, okay, well, I have 2 images running on the system, one's secure, one's non-secure. Someone may have made a secure call. I'm still getting interrupts. Those interrupts may be from a secure interrupt, it may be a non-secure interrupt. When you take those interrupts, it may cause you to do some scheduling changes. Well, how do you deal with that? And if you're only having one secure context, if you're needing to have another one, how do you transition that, and how do you get back to the original context that you had? So there's a lot of complexity there, and in the beginning, right now, it's very simple. It's synchronous, blocking, and you come back, and then you start to do whatever you were doing before. So that's how it works. So as I alluded to earlier, the Arm V8M is a little bit different. Instead of having privileged and unprivileged, you also have secure and non-secure. And there's also a new region type, so when you actually build this, you actually need to use one of the newer compilers, which I believe is you can use one of the 2017 Q4 or 2018 Q1 compiler. It's new enough to have the security extensions. What that allows you to do is there's a new region type called the secure non-secure callable, and what that is that if you have a secure and a non-secure environment, you still want to call from the non-secure to the secure. Well, how do you do that? Well, there's some secure functions you need to call, but you actually have to make the transition. So what we have here is you actually have some veneers where you make a call into code that resides within the secure and non-secure callable. And in that region, then you can actually make the transition to secure. So that's how it's done. When you create these veneers, you have to use an extra compiler option, which is the -mcmse. And that's just, if you don't do that, it won't actually do the right thing with the region. And this is a lot of infrastructure stuff that, you know, if you're writing an application in Zephyr and you're doing that, you don't, it's way down in the system. You don't really need to know about it, but this is what's happening underneath. So I'll pause real quick. Are there any questions on? Yeah. Hopefully that's on.
Hi. Just regarding the scheduling question, I guess just some knowledge from the A profile space where you know, you do have secure interrupts and non-secure interrupts. Typically, we expect the secure world to be cooperative and yield back to the normal world, so the normal world can then give the secure world some time to do its asynchronous processing. So the non-secure world's always in charge in terms of scheduling, and I would suggest that's probably a good approach in this space as well.
Yeah.
But
yeah, we hope to keep it that way.
Okay, yeah, because if you've got independent scheduling decisions going on, crazy things happen, and
right.
Yeah.
but one thing to keep in mind is, I mean, we're talking about an RTOS, right? So when you make a synchronous call into the security, you don't know how long it's going to take, and so that kind of really screws up your latencies.
True, yeah. I normally expect it's just, you know, an interrupt service routine to schedule some work and then immediately go back to the non-secure world.
Yep.
That's what I would expect, yeah.
Cool. Right. I guess you can hold on to it or just set it next to you. So how does this work from a use case standpoint? So there's kind of there's three scenarios, and there might be more, but really what it comes down to is you have Zephyr and you have the trusted firmware for Cortex-M, and you have some combination of these running on the system. So if you're running in a single environment and you just want to run Zephyr as secure, you can do that. By default, the system will run in a secure environment. The fault handlers and all that are in place, so that works fine. If you want to actually have a non-secure environment, you kind of have two choices. You can run TFM as your secure environment, and you can run Zephyr in the non-secure, or you could even run Zephyr in both. And so, in the end, if you're running both secure and non-secure, you still have to have multiple images, and whether or not you use a bootloader is really irrespective, but you have to keep in mind that when you're building both of them, you have to take into account the security configuration, because if you have any mismatch of peripheral or address space, you will get a secure fault and you will be done. So you have to be very careful about that.
Just a quick thing, Zephyr can be built without a scheduler for the, you know, the concerns about the secure side and scheduling. You don't have to build it with multiple schedulers and the nightmare that causes.
Right, and we already have a target where we do that. So that kind of leads into, this guy died? Is that the only one? I think I lost the, okay, I'll have to do it manually. Okay. Oh, I guess that's the last one, so that's why. I think Ashutosh has his own presentation. But one thing I wanted to add was, that's funny. One thing I wanted to add was that, you know, the TFM has a bunch of different components to it. There's the actual secure functions. There's the security initialization stuff that happens when you boot the system. From beginning to end, you know, whether or not you have a bootloader, if you're running a secure image, it has to configure the security in the system. And at some point, then it has to jump to the non-secure side. So there's a certain number of things that whatever secure image you're running has to do. It just has those responsibilities. And whether or not you're running TFM or you're running Zephyr, they still have to do these, they have these responsibilities. So hopefully in the future, you know, we don't necessarily want to have two different environments, two different secure environments out there that we're trying to support. We'd really rather it like to fold it down into one. And whether or not Zephyr is running as a very thin piece that actually pulls in some of the TFM components and builds the image, that's fine by us. Or if it's actually the whole TFM package. From our perspective, we don't really care which it is, but we definitely want to leverage the pieces of TFM that we want to use, whether in its entirety or in pieces. So that's kind of where I want to leave off and probably kick it off to you. Are there any other questions before we transition? No? Okay.
Thanks, Andy. I can't see my slides here. Oh yeah, there it is. No, this is the old one. 202, yeah. Do you see it? Give me one moment. It's fine. I can open the old, the ESS slides and just. I don't have a lot of presentation slides anyway. So, idea is that we go through some of the common questions which are asked by many people, and then hopefully that will open more conversation. How do I make it full screen? Sorry, I need your help, Andy. Do I need to download it? Or
It should be. Let's check that out. Should have been able to put it into the presentation mode. Go over to.
Just press present.
Present.
ah, yes, there it is.
Yeah, there it is.
Yeah. Right. So, hi everyone. I'm Ashutosh. This is again a continuation of the discussion that we started yesterday. I'm not going to repeat what I presented yesterday. I think we already covered a lot of technical topics yesterday. One of the common questions which are asked by many people is what are we implementing in TFM, and what is left for our partners and vendors to implement. So if you look at this diagram, almost everything on this side, on the right hand side, is what TFM is. It's basically all the services, the partition manager, the bootloader, and the HAL API. Well, HAL API, we limit ourselves to defining the HAL API. We cannot really implement for every single platform. And this is what a partner may need to implement. So in the ideal scenario, when we have all the software sorted out and developed and software is mature enough, for putting the TFM on a new platform would probably require just rewriting some of the HAL APIs, and that is where most of the contribution should come from a partner platform. Having said that, there will be, at least in the beginning, there will be some uniqueness in every single platform when it comes to the actual hardware implementation. So that will lead to the evolution of the HAL API itself, where today we are going to define on the basis of what we think is the best HAL API. But with more platforms coming in, more contributions coming in, this is going to evolve, this is going to change. So, and this is where I expect a lot of feedback from our partners as well. Any questions, suggestions? Yeah?
Does ARM provide standard drivers in TFM for all of the standard IP blocks that you might include in a Cortex-M processors, things like CryptoCell, UART, counters, that kind of thing? Or is that something you expect?
I'll come back to CryptoCell in the second part. Let me first address the generic question about all the drivers and all the IPs that ARM produces. Purely from TFM perspective, yes, whatever TFM requires, we do provide, and we will continue providing support for the newer IPs, for most of the IPs. CryptoCell today is not open source, so we can't really upstream the driver as it is. Yeah, so that's where we stand. You want to add something?
Just for the ARM systems or others as well? TFM provide the implementation of these APIs?
I think his question was more of ARM, about ARM IPs itself. And
it was largely about when you hand out TFM to partners, is there a good selection of ARM IP already supported in TFM so that if I create a Cortex-M SOC, that I don't have to go re-implement UART driver for TFM? It's kind of the same problem we have with Linux and U-boot, right?
Yeah.
Every single driver from the Linux kernel eventually gets pulled into U-boot to the point where you go, why don't I just run Linux?
yeah, so if you're comparing with Linux kernel, it is not at that maturity level. It has taken many years to mature in Linux kernel domain. You have device trees where you can basically have same driver handle multiple instances of and multiple variants of the similar IPs. We're not there yet. That's the ultimate goal, yes. We do provide a reference implementation for the IPs which are in the reference platforms. We'll continue adding support for more IPs. And that's where we are.
Just regarding CryptoCell, I'll ask you that for TFA project at least, that even though the CryptoCell driver itself is proprietary, the interface is upstreamed, and there's a kind of a glue layer between the main project and CryptoCell APIs.
Yeah, and that's where in one of the slides here. So this is again from yesterday. Yeah, so one of the ideas behind this blue box is to standardize the integration of crypto accelerators. So you might have a different hardware down there, but that shouldn't affect the implementation of the rest of the system software. So this is what we are trying to abstract, mostly here, mostly in the HAL API, but sometimes the quirkiness of different hardware may require taking some of the understanding of the hardware into this box itself. And the effort is to contain the uniqueness of every hardware only in this box. Yeah.
Okay. How are you addressing SIMSYS? Are you actually, is the HAL API SIMSYS based?
Yes. Most of the HAL interfaces that we have today is SIMSYS interface.
So there's a need to clarify that that's TBSA. This is TBSA-M HAL APIs, so it's not generic device drivers for every ARM IP that's produced. TBSA requires certain components to be part of the platform. That platform may have many other components. We don't need those. For simple debugging, there might be few IPs, but the trusted site won't start implementing all sorts of drivers, which is, I think, something what you were referring to, Naiman. It's not going to take all of the embed drivers or all of the Zephyr drivers, need them here as well. There are specific components in TBSAM, and they will be supported here, plus some additional things. I think that's what is worth clarifying.
Thanks, Abhishek. Yeah, so TFM is going to implement only what is required by TFM. It will not be a repository for general purpose drivers for the non-secure side. Yeah. Where's the mic? There's one there.
So, since you said the question was, what are you doing in TFM? I mean, is there any roadmap that is publicly available for people to see?
I think Shiva is going to cover it in one of his talks about that.
Okay. So,
Yes.
and about, are you from ARM the only one doing the work so far? Do you have external contributors to the project, or is it mainly ARM people?
You were our first external contributor.
Okay.
We are starting to engage, but so far it has been mainly ARM.
So on the roadmap, it's publicly available now in tf.org. So there is a dashboard where what are going to come in the future quarters are all captured. So it's publicly available, and it will be sort of covered in the high level in today afternoon's presentation.
Right, so coming back to the big picture, as I said, the ultimate goal is to abstract the software in a way that it requires minimal level of change for when you want to port the whole TFM on a new platform. It will take some time to get there, but when we start getting more platform contributions, this will start getting more mature. Right now we have support for mostly ARM platforms, and when we start seeing the variations and we start seeing more colorful hardware coming in the play, is when it will start getting more mature. Any more questions on this? No? Okay. The other general question that I wanted to talk about was interrupt handling. This has been talked about quite a few times already. There are two aspects to it, the non-secure interrupt handling and the secure side interrupt handling. The effort is to make sure that whatever we do in the secure side shouldn't have any impact on the real-timeness of the non-secure side. The current implementation basically, it blocks everything in the non-secure world. Once you have made a call to the secure world, it will not return, it will not yield before it finishes what it is supposed to do. But that is just interim solution to allow us to make more development and allow us to start developing our software. Ultimate goal is to allow preemption of the secure side execution. And so if you're running a service on the secure side and a interrupt comes on the non-secure side, it will be able to preempt the secure side execution. That is, so then you're talking about the A-class world where the non-secure side interrupt is always handled, doesn't matter where the execution is. There's a subtle difference here between the A-class world and the M-class world. In the A-class implementation, most of the time the interrupt is routed through the secure world itself. Usually you'll get the non-secure interrupt in the EL1, then probably it will go to EL3, and it will come back to non-secure EL1. In TFM, we are trying to not involve secure side for handling non-secure interrupts, because there are a lot of real-time concerns here. That there are a lot of routing has a cost. If you want to handle all the interrupts in the secure world first and then decide to route it back to the non-secure world, it has a cost. So our current designs are geared towards no matter what's happening in the secure side, if a non-secure interrupt comes in and if it has sufficient priority, it will preempt the secure side execution, and it will handle the non-secure interrupt. Now the onus is on non-secure side software to restore the preempted context. So if secure side is executing something and a non-secure interrupt comes in, the secure side context would have been preempted. Once the non-secure side takes the control of the execution by the fact of handling the non-secure interrupt, that time it is in it is in charge of the whole execution. It can decide never to go back into the secure world. It can say, fine, I have got the control. I'm going to schedule every single non-secure world thing that is there on the plate and not yield back at all to the secure world. So there is a denial of service aspect to it. There are ways to mitigate it, and there are ways, and the mitigation could be very use cases specific. I'll get into that maybe in a minute. But so the first point I was trying to make, non-secure execution and non-secure side software should be, the design principle that we are trying to follow is to minimize the impact on the non-secure side software and its real-timeness. That means there is onus on non-secure software to return the context back to the secure side once it has done the critical part of the interrupt handling. Yeah.
Thanks, Ash. Yeah, I mean, you're right when you say the difference between TFA and TFM is that there has to be a secure entity, whether it's EL3 or secure EL1 to handle that transition. And so, but one of the other reasons that things get handled on the secure side first is that, the secure OS vendors like to, if you're going to go do things like certifiability, you need to prevent things like preemption, and there has to be some sort of controlled exit from the secure world, so the secure world has time to sort of do some bookkeeping or whatever else before going back to the non-secure world. Now, I think you're right, this is probably a different environment, and your design probably makes sense, but it's something worth thinking about if you want to sort of certify the whole, whether you're looking at certifying the whole system or parts of the system and things like that.
That makes perfect sense. When I started to think about the design for the secure side scheduler for the TFM, I looked at some of the existing implementation, and I looked at the OPTI. Joachim, you're probably going to contradict what I'm going to say, but I'll say it anyway. When I looked at the OPTI implementation, it helps a lot if you do the routing from the secure world, because then you can have a sane exit from the secure world. Your scheduler, the secure side scheduler, is in sync with whatever is happening on the CPU. So it makes a lot of sense to do that kind of routing from the secure side software point of view. It makes the scheduler implementation a little easier, not a lot, but because you have a controlled exit and controlled entry, you don't have to worry about too many asynchronous events happening in the secure side scheduler. The other aspect is having a control about the secure side execution and secure side being in charge of what's going on in the whole CPU. The current thinking is that if there is a time critical event on the secure side that need to be handled, that should be based on some sort of trigger, some sort of interrupt, some sort of watchdog, or something, some way, something which will asynchronously take the control back into the secure world. So if you have some sort of tamper resistance mechanism, that should have the interrupt for tamper resistance mechanism should have high enough priority to preempt the non-essential things or less security critical things from the non-secure side and take the control back into the secure world. So that's the approach. Yeah,
that makes sense. I guess you just got some complexity around, things that maybe you don't see in the secure world, the normal world preempts that, and then something higher priority in the secure world preempts that, and you've got all these kind of contexts all running at the same time.
There's quite a bit of complexity there.
I mean, I think one thing to point out, you mentioned the denial of service from the non-secure to the secure side, and I think it's easy to see those where they're actually not really significant because there's so many other ways that you could deny things from the non-secure side. I mean, for the most part on these platforms, things like network communications are happening from the non-secure side, And if you've compromised the non-secure side, you can prevent that from happening too, and it wouldn't matter if you stopped a key signing from happening if you don't hand the data across anyway.
Yeah, absolutely. And so denial of service for the use case is very difficult to mitigate. However, the denial of service for the security use cases for the device itself, so if some tampering is going on for the device, those are the things which are a bit even more serious than the use case level denial of service. So if some tampering is going on, you would want to be able to handle that irrespective of what non-secure is trying to do. So those are the things that need to be handled asynchronously on the secure side software.
Is there an issue making it policy-based so that you might only interrupt if it's a high criticality interrupt and not if it's a low?
So the VTM architecture allows you to set a policy that you can prioritize all of the secure side interrupts with the offset. What that means is every interrupt on the secure side will have higher priority than every non-secure interrupt. But yeah, so every secure side interrupt can be programmed to have higher priority than the non-secure side interrupt, but that's a policy decision. That's a policy decision for device and use case. At the architecture level, we are not going to limit that. We will provide an option to do that, but we're not going to limit that as a overarching solution.
When you were saying that the non-secure side could get an interrupt that interrupts the secure side, and so there's a responsibility for the non-secure side to not block for so long. But how's the context on the secure side restored then? I mean, where's that occurring, or how's that happening? Because it seems like that's an attack vector that could be taken advantage of from, particularly if you've got networks traffic, being streamed in.
Yeah. So a lot of this is handled in the hardware itself. The non-secure side doesn't get to see the context itself. So it knows that it has preempted the secure side, but it doesn't know what context what was the actual context frame, or what was the execution happening on the other side. So the ideal implementation would be that non-secure side takes the interrupt, runs its interrupt service routine. At the end of the interrupt service routine, it has to realize that it had preempted secure side execution. So instead of doing its returning to its own thread context, its own scheduler context, it has to do a return to secure. So the LR value, the link register value, there is a magic number that you need to use when you do a return, and that magic number is coded to, there is a coding for that LR value. If that specific LR value is used, the hardware knows that it is a return from non-secure side execution to the secure side preempted context. The hardware itself does the restoration of the context.
Is there a request to the architecture team to fix this so that the hardware would just know that when the non-secure side returned, that it had preempted security, would just go back there, right? That it's transparent to the non-secure side.
So is the question that we need to have a hardware level solution to not allow non-secure world preempt the secure side execution?
I'm saying that, so there's still a denial of service if the non-secure side doesn't ever decide to return from its interrupt. Yeah. But when it does do the return from interrupt, that should just go back to the secure side without any knowledge that that's where we preempted from, right?
Yeah.
Is that how it works?
That's how it works.
Oh, okay.
Yeah. So there's a lot of
so there's no fix-up of software or anything that the
no, there's no
software
software
side.
here.
Okay.
There's no software here, and there is there is protection against malicious return as well. So what you could do is, even if there was no preemption, you could just say return from the non-secure world to the secure world, and that if that is not mitigated, that can allow preemption, restoration of a context which was never there.
Is there?
So there is a protection against that as well.
Okay. Is there, from a software side on the secure, if you re-entered through a different path, So let's say I get an interrupt, I go back to non-secure for whatever reason doesn't actually return,
Yeah.
and then I make another transition through another call. So now I'm, the non-secure is in this kind of odd software state. Is that something we're dealing with?
Yes. So the non-secure side can decide at the end of interrupt service routine, it can decide to schedule another non-secure task. And that can create another entry into the secure world. I guess that's the scenario you're trying to address.
I think it was more directly from an interrupt handler. If you took an interrupt and you interrupted the secure world, secure interrupt handler or whatever, and then the interrupt handler made a secure call in, I mean, do we handle that? Is, I guess, the way I understood the question.
The idea is to not allow call into the secure world in any of the privileged states. So I'm not sure if you were there in yesterday's call, but recently we made a change that transition from the non-secure world to the secure world can only happen in the thread mode on the non-secure side. So if you make a call from the interrupt context, that just gets rejected by the hardware itself. So having said that, I'll just give one more moment. Having said that, the non-secure side can still decide to schedule another task on the non-secure side. And that task, the second task, can decide to make another call into the secure world, which is a perfectly valid scenario because that's how your preemption works.
But you're out of the interrupt handler at that point.
You're out of the interrupt handler, and then the scheduled task can make another call into the secure world. And this is a scenario that will be handled in the scheduler design.
So that has to be handled on the secure side in software, though.
There is a lot of
the
software.
notion of
yes.
what context you're coming
So
back
there
to.
is a lot of software that need to go to handle that kind of scenario, and it is quite complex, as you can imagine.
But to clarify one thing,
Yeah.
when the non-secure interrupt handler occurs,
Yeah.
it actually needs to check to see if it interrupted a secure handler so it could do the special code back versus a regular return?
So when you look at the scheduler, essentially it's the scheduler that does return back to the any context. Any context restoration or preemption is handled by the scheduler code. And when you look at any of the scheduler code, what it will do is it will not look at the content of the LR. It will just try to restore whatever was there in LR. And the hardware makes sure that the LR value, when the preemption happened, LR value is the return to secure magic number. So when the scheduler decides to go back to the secure world, the non-secure scheduler, when it decides to come back to the old context. So from the non-secure scheduler point of view, it doesn't really need to know if it was a secure side execution that got preempted. For all it knows, it was just a non-secure task which got preempted by another context. From the non-secure scheduler point of view, it just preempted its own task, and that task would have been saved by saving the LR value. And when scheduler decides to go back to the preempted task, it will just use that LR value which was there in the TCB, and that will magically take the control back into the secure world.
So would a simple answer to that question be there are no changes needed to the non-secure side?
Yes. Yes.
Okay.
I was just going to say, if you use TFM, you don't have to change your scheduler on your non-secure RTOS.
Yeah. Yeah, so that's what we're trying to do in all the design decisions that we're trying to make, is minimize the impact on the non-secure side software. There is a subtle impact there. I'll talk about that if we get some time. Nariman, where's the mic?
So this is probably a dumb question, but I'm going to ask it anyway, because I'm clearly not clever enough to filter myself. But we have Opti guys in the room, we have TFA guys in the room, TFM guys in the room, Zephyr guys in the room. I've worked on Opti, I've worked on TFA, I haven't worked on TFM, but what strikes me is that we could probably do with like some unified view of what the driver model should be, because I have a feeling that there's going to be like 613 different UART drivers, all with their individual bugs in each of these projects. And it would probably be good if there could be, even if you don't have a unified driver model, some agreement on how you interact with the driver, so you could easily write glue code so that public drivers can have unified bug fixes to them for behavior in the IP. Because after all, you're going to be talking to the same hardware most of the time anyway, right?
I think it's a very valid problem to attack. However, it's slightly beyond the scope of TFM, because TFM is going to talk about very niche drivers, which are always going to be used by the TFM. So maybe there is a value in standardization there. I don't know today. There is definitely value in learning from other people's work. How much standardization we can do for things like SAO or things like PPC, MPC. Yeah, and it's in a way it's standardized anyway by SIMSYS.
But yeah, I guess it's as more, because you never know what thing's going to get pulled into the secure world. Sometimes people might want to go, actually I want secure world to be in charge of all the networking. I don't want the normal world to be, and we're going to have an API for doing that. And suddenly you're going to have to pull in networking drivers, perhaps, right?
Yeah.
And at that point, do you want to rewrite do you want to rewrite from scratch network drivers for TFM, or do you want to be able to leverage something that's been done elsewhere? Because I know that maybe Opti might have a network driver, or TFA might end up with a network driver, and at that point you want to be able to go, okay, but I don't want to adulterate the logic that deals with the IP. I'm happy to glue it in, but, and I know Abhishek says that obviously you have the CMSys interface, but
yeah.
Really it's the fact that bug fixes across, like that deal with the IP, it would be nice to be able to aggregate those across the projects in a sane way, rather than having to do a specific bug fix for each project, given that you're going to be dealing with the same IP. That's all.
Yeah, that makes perfect sense to me. And a lot of drivers that we use in the embedded software world anyway is usually borrowed from some standard code base. So in a way, it is kind of taken care of, but not really, not to the extent that you're proposing. And I see that there is value in keeping everything aligned and making use of the common knowledge pool. Yeah. How are we doing with time?
Maybe last question or so.
Okay, in that case. Any more questions? Yeah.
So on the current implementation, what is exactly supported, in fact, in terms of preemptions?
Yes. You are part of the crypto service. You have quite good secure storage right now. The split between, so you don't have any of the blue boxes today. Some of this is going to be split and blue boxes will start appearing. We have the SPM, we have the bootloader, and they will also evolve with time, and they will also have new features, things like scheduler, things like interrupt handling will keep coming. But at the block level, this block is there, this block is there, this audit log block is there, secure storage is there, part of crypto is there. This will appear soon. You'll see some things appearing in the next quarter. And of course, the user-facing APIs. Yeah. That's it from my side. Thank you, everyone. I'll hand over the control to Joachim.
All right. So we're going to switch gear a little bit to something different. So this is a question that will come up sooner or later, no matter what you're working with. So I usually talk about a certain project, but this could be something for any project that deals with some kind of secure software. So even though it's open source, I mean, as soon as something has been reviewed and it's been merged, usually it takes quite a while until someone actually pays more attention to the code. And that's why we need to have some kind of audit or some kind of review of the code. And I will not give you any answers here. I want you to give me the answers. So I'm just presenting the problems. So how can you do that for an open source project? If we compare it to other bigger SoC vendors, OEMs and so on, they are doing this on their own. And in this case, for example, for Opti, we have seen that some of the vendors, they have done audits, but we don't really see the results from the audits going back upstream. So that's one of the problems that we have here. So you can try to raise some kind of funding for it. So you can go with, for example, HackerOne, if people are familiar with that. So you can get a bunch of different skilled hackers in a certain area, starting to pound on your software and trying to break it, basically. We have the CII initiative from Linux Foundation also. That is something that you don't really need to raise any funds in that case, but then you need to convince Linux Foundation instead that this is something useful to do. We have the other usual problems that show up when you start to discuss this. When you do this kind of audit, what kind of hardware should you use? If you ask a guy from TI, for example, they would say use our hardware. High Silicon, as I say, use our hardware. So that's also a challenge here because you need to find some kind of suitable hardware. And a follow-up to that is finding a suitable release and commit where you should do it. And the most obvious thing is probably to just take some kind of stable release and make it on that. But open source software, as you all know, is quite rapid development. So you have some kind of certified or audited code base, and just 2 weeks later it could be kind of not really valid anymore. The final thing that is share the results was, the first thing I said, basically, that we have seen that some companies are doing it internally, but it doesn't really reach upstream. But you can, companies like Resecure, Atlas, they're well known in this area for doing audits, reviews and such, but it's not for free, if we say so, which leads to the raised funding. But I don't know, so I ask you for ideas here. What do you think one should do in an open source project when it comes to audits? And is it needed? I guess that's a yes, I guess, for everyone. Any comments?
Yeah, so with our open source software, we have a small hypervisor system. We usually do this as part of customer projects. And typically we do that when the customer builds this into some kind of application that needs certification. So it gets certified as part of a bigger project. And if we want to get it certified in isolation, then the way we do this is typically to invite customers to co-invest into this with us. And then in exchange, they get some extra from us as a company, such as a commercial license or some extra service or something like that. So usually we invite investment in order to get our code certified and looked at after it has been written.
Share the burden a little bit.
Yeah.
Stuart?
I mean, it seems like, the raising the funding would be to get like a bug bounty or something like HackerOne to have people, try to break the code. I mean, it seems like Linero is in that position to, with the member companies to maybe, I don't know, to kind of have them all, to have a specific maybe fund or something for a specific project to say, hey, everybody, if we all contribute X amount, here is the benefit from it. And because I'm sure the groups don't currently have the funds. They don't have thousands of dollars to put for bug bounties, but maybe there's some way Linero can coordinate that, because it seems like the companies, it's not going to happen without some central entity trying to encourage, participation. There's probably only a handful of companies that are going to, maybe ARM should do it too. Maybe ARM should try to encourage bug bounties. And
we actually roughly a year ago we had a discussion about this, so we kind of asked our members. We had a ticket in GR about HackerOne and asked who are interested in this, and there were interest, but again I guess it failed on the things I mentioned here, finding suitable hardware. Some reported back saying that we have already done it, we don't want to do it again, and so on. But on the other hand, This is something that you need to do over and over again. You can't just do it once.
Yeah.
So, but it's a good idea, and it's something we've already been touching a bit.
Hi, yeah, I think there are some ongoing activities, like you said, like you obviously have to keep auditing, but there's probably some upfront stuff as well that needs to be done just once, and that's probably what I want to look at first. Things like threat modeling, coding standards, training for the team, all these things, and that's probably easier to tackle in a one-off sort of funding round for the project. And then I would agree with Michael that the ongoing auditing and hardening of that is probably something that requires a separate commercial agreement, and maybe is not actually part of the open source offering itself.
Right. Yeah. Some of you maybe remember TrueCrypt. They did I think it was a Kickstarter or Indiegogo or something. So they raised some money to get some people to look at the code, basically. That's also something you can do, but then you need to have a project that is, well, TrueCrypt, everyone in the world was using that. That's quite easy to say that this is something that we should do. But for smaller projects that still would need a lot of eyes, I think that could be a little bit harder to do.
Yes, to come back to your point about TrueCrypt, everyone was using it, and that's kind of my point, is that it's hard to crowdsource security researchers, given that if you haven't got something that's in the hands of everyone, or if you haven't got something with wide distribution, because that's part of the allure, right? Either you put really high bug bounties, and then people aren't like, oh, I won't get that much cred for it, but I'll get $10,000, so I probably still do it, right? Or you go, everyone has a Samsung Galaxy S6. If I break, voice biometrics on this, then I'll have loads of street cred, so I'll probably do it anyway. But if you're in the middle where you need loads of eyeballs, but you haven't got a product out there, then I don't know. It feels like Dan said, it feels like you kind of need to go back to basics before then.
Right. Yeah. Anyone else? Michael?
I wanted to comment on the challenge that you want to maintain the audit state. So we found this especially hard to do with open source software. And while it's possible to maintain a certified state, I don't think it's possible to maintain an audit state. And in both cases already you need a lot of organizational investment, like you need to implement processes and stuff. And that's really hard to do even for us as a company. It's even harder for a cross-company or an open source project, I think. I think it's possible to maintain a certified state because they come with change management procedures that you can implement even as an open source project. But maintaining the audit state is, I think, impossible for an open source project.
So you believe that that's more like a snapshot you do one time and find all the most critical bugs and so on? Yeah. Could be. Okay. Any more questions? Okay, well, that's it. Thanks.